This is a mini lesson for graphing absolute value equations, which is a challenge topic. On this page, you will see some definitions and you'll see some steps, but I'll go through the examples. So first, we have to remember that the general vertex form of an absolute value equation looks like this, where hk forms our vertex. We know that this will always be either the minimum or maximum of the v, so it would be like this point here or this point here. And we also know that absolute value equations, in addition to being a v made up of two rays, are always symmetrical. So we're going to start by making a table of values, and we want some workspace in the middle here to do our work. And we want to include at least 5 points, and I like to put the middle point as my vertex. So my vertex here is my hk. So in this case, it's -3, -2. Make sure you have a -3 because we know that we have a minus the h. And to be more specific, we can take whatever is in the absolute value and set it equal to 0. So x plus 3 equals 0 gives us x equals -3. That's the x coordinate of the vertex. We'd plug that back in, and we'd get negative absolute value of 0 minus 2. So then I'll pick some values on either side of that. So I'm going to do -4, -5, -2, and -1. And so I do some mental math in here, but so we have negative absolute value of -5 plus 3, so -2, minus 2. And I think, okay, well, this is really -2, minus 2 is -4. The next one I'm plugging in -4, so I have the opposite or negative absolute value of -4 plus 3, so -1 minus 2. Again, this becomes positive, so we have -1 minus 2 is -3. And we're hoping to get these same values. This should be symmetrical down here. So let's plug in. So we have negative absolute value of -2 plus 3, that's 1 minus 2. That's -1 minus 2 is -3. And then negative absolute value of -1 plus 3, so that is the absolute value of 2 minus 2 is -4. So we're happy that this is symmetrical, and so I'll plot these points. I have -5, -4, -4, -3, our vertex at -3, -2, -2, -3, here we go. And so here's our absolute value, and we can do a few things to check that. So the first is we can make sure that this does in fact have the right vertex, -3, -2. We see that this negative out here for A tells us that we're going to be reflected down. So our V, you could think of it as upside down in terms of the actual letter V. And our slopes here are 1 and -1 because there's no coefficient here with the x. In our next example, we'll have something a little more complicated. So I'm going to set this inside here, 1/2 x minus 3 equal to 0. Add 3 and then multiply by 2, so I get that the vertex occurs when x equals 6. I can imagine that out here, the plus k would be plus 0, and we would get that also if we plugged in our 6 into our work. So our vertex is at 6, 0. So I'm going to draw up my table. Again, I like to put the 6, 0 in the middle. If you wanted to prove this to yourself, half of 6 minus 3 is 3 minus 3 is 0. And then we want some points on either side, but since I see that there's a coefficient here of 1/2, I'm going to choose to put in even numbers to avoid fractions. So I'll do 2, 4, 6, 8, and 10. So again, half of 2 is 1, so the absolute value of 1 minus 3 is the absolute value of -2, which is 2. Then I have the absolute value of half of 4, so 2 minus 3, which is -1, so the absolute value of that is 1. Hopefully we get something symmetrical over here. The absolute value of half of 8, so 4 minus 3 is the absolute value of 1, which is 1. And the absolute value of 5 minus 3 is the absolute value of 2, which is 2. So I have the point 2, 2, the point 4, 1, point 6, 0, 8, 1, and 10, 2. And again, I can do a bunch of things to check this. So first of all, I know that since the coefficient out front, there is no negative, it should be aimed up. I know that my slopes will be 1/2 or -1/2 here. I know that my vertex will be, from this I'd get 6, and then I'd get the plus 0 here, so 0. And this is symmetrical. So you can always check out the steps down at the bottom and the reminders, but hopefully these examples helped you to learn how to graph absolute value equations.